Okay, guys, let's go ahead and continue with the questions. This one should be number 12 for you all. It states which question can be answered by reading the box plot. A, what is the mean? We know this is incorrect because this line here does not show the mean, it shows the median. B, which data value occurs the most frequently? We know that this is incorrect because the box plot actually doesn't show frequency. There are other charts that do that, but this one does not show frequency. Frequency is telling you how many times was that number represented, and we cannot see that. C, how many data values are there? We can't see that as well because we don't know what the exact data is in between the box and the whiskers. And then D, between which two numbers is the middle half of the data. And we can do that because we know that right here we get the median. So you should have chosen D. Okay, let's go ahead and try this question. Which of the following are accurate description of the data distribution shown below? Select all that apply. Make sure that you're labeling this number 13. A, the distribution is skewed to the left. Well, the tail is on the right, so actually this is skewed to the right, not the left. So that's not an option. B, the distribution is approximately symmetrical. Symmetrical means that the box is in the middle and then the whiskers on both ends are about the same distance, and as you can see they are not, so that's not an answer. The distribution is skewed to the right. This would be correct because the tail is on the right, so we're going to go ahead and check C. The mean price is $7. Let's go ahead and check. Well, they almost got me on that one. It says mean, and this does not state mean, so that's not an option. But the next one says the median price is $7, so that would be an option. Because let's remember that this line in the box is the median. The interquartile range is $7. Okay, once again, to check the interquartile range, you have to subtract this value, which is 13, from this value, which is 6. And just a reminder, this value here is called the third quartile. This value here is called the first quartile. And you would subtract those two numbers to see what you get. And in this case, you do get 7. So F is an option. Your answer should have been C, E, and F. Oh, sorry. Okay, let's go ahead and try this question here. This is your number 14. Okay, it states the following data represents the number of times a river has flooded per year for the past 10 years. It then gives you your set of numbers, and then it asks you what is the interquartile range of the data. I'm going to say it one more time. Interquartile range would be determined by using a box and whisker plot, but we can actually also do it by rearranging the numbers. So let's go ahead and do that. Before we create a box and whisker plot, our first step, if we look back over here, was to, well, I don't have it on there, but our first step here was to go ahead and, oh, here it is. Okay, was to go ahead and rearrange from least to greatest the numbers that were given to us in the number set. So that's what we're going to go ahead and do. Let's see what we have. We have 1, 2, 2 2s, 1, 2, 3, 1, 2, 2 4s, 1/8, and 1/10. I'm going to go ahead and turn this. Okay, so now that we rearranged the numbers, we can go ahead and figure out what the median is. Okay, so there's two ways to, well, let's go ahead and do it this way. We're going to go ahead and cross this one out, 8 out, 2 out, 4 out, 3 out, 4 out, 3 out. And our median is 3. Okay. When you're checking median, just make sure that you have the same amount of numbers on the left side of your median that you do on your right side. So we have 1, 2, 3, 4, 1, 2, 3, 4. So yes, this is an equal amount on both sides, which means that this is our median. Okay. Once you have your median, your interquartile range is basically getting your median on both sides of your overall median. So we're going to go ahead and work on the left side first to get your first quartile, and then we're going to work over here to get your third quartile, and then we're going to subtract them from each other, and that's how you get your interquartile range without creating a box plot. There are two ways, remember? The first way is creating the box plot. If you wanted to do that, you can, but you know, FSA is timed. The second way is just going ahead and getting your overall median, and then getting your first quartile, and then your third quartile, and then you want to subtract this quartile from this quartile. So let's go ahead and try that. All right, so we're going to cross out 2, we're going to cross out 3. When you're trying to get your first quartile on the left-hand side, do not include the median. That is now out, so don't include it. We now have 2 numbers left on the left-hand side. So to get that median, we're going to do 2 plus 3 equals 5, divided by 2 equals 2.5. Okay, so this is 2.5 for the first quartile. And now we're going to work out the third quartile, which is everything to the right of your overall median. So this is crossed out, this is crossed out, and we're left with 2 in the middle. So we're going to go ahead and do 4 plus 8 gives us 12, divided by 2 gives us 6. Okay? And that is our third quartile. Let me just wrap this up one more time. So here's our median. We lined everything up from least to greatest. We got our overall median, which was 3, and all you had to do was make sure that that was the middle number. When it talks about getting the interquartile range, that's working on getting a median for everything to the left of your overall median. So we did the same thing, got the middle number to everything. Got the middle number for all the numbers to the left of the overall median, and then we did it for the right side. Okay, so now that we got our 2 numbers, which are 6 and 2.5, you want to go ahead and subtract them from each other. So we're going to do 6 minus 2.5. Since there's not a decimal here, you want to go ahead and add 1 behind the 6. Borrow. 10 minus 5 is 5. Remember, when you're subtracting decimals, you bring down the decimal. 5 minus 2 is 3. So my interquartile range would be 3.5. Okay? Just make sure you try to work this out. If you didn't figure it out the first time, just replay this question. If you have questions on this one particularly, make sure you ask me a question so we can go ahead and make sure everybody understands this. All right, let's move on to this one. This should be number 15. It says the following data points represent the number of guests at Hunter's Ribeye Barbecue House each day since they opened. Display the data in a histogram. Okay, so they already broke up the categories that they want you to use. So for these categories, they want you to use 0 to 100, 100 to 200, 200 to 300. Okay, so before we start, I'm going to go ahead and create a frequency table so that we can have this data already figured out and we can have it tallied up. So 0 to 100. That's your number of guests. And this is, I'm writing tallies, but you can write frequency. So numbers between 0 and 100, we have just one. We have 75. So we want to go ahead and put one tally. All right, numbers between 100 and 200, we have, oh, I'm sorry, I didn't see the 96. So we actually have 2. Okay, between 100 and 200, we have 1. We just have 1. Between 200 and 300, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I'm going to go ahead and make my histogram. So remember that the bars do not have any space between them, okay? So we're going to go ahead and start here. From 0 to 100, go up to a frequency of 2. Now you want to make sure if it's 0 to 100, you're making a graph from 0 to 100. Alright, next grouping is from 100 to 100. So you want to begin at the previous bar. It's just a frequency of 1, so we're going to go here to 1 and then go down to 200. Now, obviously you want to make it a little bit straighter than that, but hey. For 200 to 300, we have a frequency of 1, 2, 3, 4, 5, 6. So we want to begin at the last bar, go up to 6, go all the way through to 300. And it should look like this. So hopefully you got that. I mean, obviously it'll be straighter though. I'm going to move on. Okay, this should be number 16. What is the solution to the equation 4w equals 2/3? Okay, so we're going to use inverse operation to solve any equation. So we have 4w equals 2/3. We always want to isolate the variable, so go ahead and circle your variable so you know what you're trying to solve for. With an equation, you are solving for something because there's an equal sign. So we're solving for this variable w. This states 4 times w. To solve for any variable, you always want to do inverse operation to get that variable alone, because we want to get this variable on one side of the equation by itself. So right now it has 4 times w because there's nothing in between the 4 and w, which is letting you know that that is a multiplication problem. To get the w by itself, we have to do inverse operation, which will be division. So you want to divide it by the same number attached, because 4 divided by 4 will cancel out. But whatever you do to the left side, we have to do it to the right side. So we're going to now do 2/3 divided by 4, and that turns into 2/3 times, because we're going to turn the 4 into a fraction, it's going to turn into 2/3 times 1/4, because we did keep, change, flip. We're then going to get 2 times 1 equals 2, 3 times 4 equals 12, and you're going to look up here, check to see if you see an answer. I actually do see an answer. They didn't simplify it, so we're going to go ahead with the answer that we got, which is 2/12. Okay, number 17. It states graph the inequality x is less than 1 1/2. With inequalities, you want to remember if there's no equal to sign, that the circle is a open circle. So we're going to go ahead and go to 1 and 1/2. We see 1 and 2, so we know that it's going to be somewhere in between here. This is 1 and 1/2. Here we are, because that's halfway between 1 and 2. So we're going to go ahead and make a circle. And if you ever get confused, obviously it's stating that x is less than 1 and 1/2. Okay, so anything less than 1 and 1/2 could be x. But if you ever get confused, look at the arrow. The arrow will let you know which way to go ahead and draw your line. And if the arrow is facing to the left, we're going to draw a line to the left. See, the arrow is facing to the left. If the arrow was facing to the right, we're going to draw our line to the right. But in this case, it is to the left. Remember, leave the circle open if there is no equal to sign. Alright, let's go ahead and try this one. This is number 18. I'm going to give you a chance to read it and actually attempt this on your own, and then I'll give you the answer for this one. A national park charges $26 per adult and $16 per child for rafting down one of their 2 rivers. Write an algebraic expression that can be used to represent the total cost for A, adults, and C, children to raft down the wild river. So it's telling us an expression, so we're not going to use an equal sign. It's also telling you exactly what letters or what variables they want you to use. So for adults, they want you to use A. So we know that A, adults, charge $26. And they want us to find out the total cost if there were children there as well. So we would write plus and C for children, and they cost $16. Obviously, I would go ahead and always flip this around. I always like my numbers in front of my letters. But either one is okay because, as we know, multiplication order does not matter. Okay, I'm going to go ahead and move into this one. It says draw a line from each equation to the operation that can be used to find the solution. So this is just making sure you know that you have to use inverse operation to solve any equation. So if this is x plus 5 equal 9, we're going to have to get this 5 onto the other side of the equal sign so that x is alone. And the only way to get rid of the positive 5 is by doing the opposite, which is subtract 5. So this would go there. This is 4x equals 20. We have to isolate that x and get it alone. The only way to get rid of a multiplication is doing the opposite, which is division. So we're going to have to go ahead and divide this side by 4. Let's see if we see that. Here we go. Divide each side by 4. Here is 5x equals 20. We're trying to get that x by itself, so we're going to do inverse operation, and 5x means multiplication, so 5 divided by 5 will get rid of that 5, and we're going to go ahead and choose here. X minus 4 equals 9. The opposite of subtraction is addition, so we're going to go ahead and add 4 to each side. And this should look like this, plus 4 plus 4. Just remember that the whole point of equations is to get the variable, whatever the variable is, on one side, and then everything else on the other side. So if you look at this, this is your equal sign. You have to have the variable on one side. It can either be all on your left side or your right side, and everything else here. Okay? It just has to be on one side.